let's start with number 4. Now, number 4 is the chain rule with respect to the power rule. So, with this, I know some people don't like the u and the u prime, but I like u and u prime. I'm going to let u be equal to the stuff that's inside. So that's 5x squared plus 3. What would u prime be?
10x
Plus nothing, right? So now, y prime, the derivative of y, or dy dx, if you want to think of it like that, that's going to be 4 times 5x squared plus 3 to the third power. Now, is this x? So that I have to take the derivative of that, which is 10x, which we already figured out. Now, if you use the u and the u prime, you just do a u substitution to get y is equal to u to the 4th power. Y prime is equal to 4u cubed times u prime. That's how we generalize. We take it away from x to the nth power and take it to u to the nth power. But u is a function of x, so we have to take, that's the chain rule. So that's what the chain rule actually ends up doing. Now, in this case, I would expect you to simplify this to 40x times 5x squared plus 3 cubed. Because that is a simple step. So, I guess when I ask you to simplify stuff, a general rule can be clean it up as nice as you can. But don't break your back over it, because that's a waste of time. Alright, does this make sense? Pretty soon, hopefully, you guys don't have to do the u and the u prime when you're doing your chain rules. Yes, you can. If you don't need it, don't do it. But if you need it, and I think you'll need it more when you get to your product and your quotient rules, because that's when it gets a little bit more, a little bit more. All right, are we good with this one? Yep, hopefully. All right, number 7, going the wrong way. Anybody see Planes, Trains, and Automobiles? Steve Martin, John Candy. No, it's a movie. They're driving on the wrong way of the freeway, and the people on the other side are waving them down, and they're waving, and they roll down the window, and the people on the far side of the freeway say, "You're going the wrong way." And John Candy looks at Steve Martin and says, "How do they know where we're going?" It's a great movie. Yeah, how do they know where we're going? All right, now, this is going to be in your do's and don'ts of calculus. One of the do's is put things in a form that's easy to differentiate. I didn't make that video yet. Give me a little bit of time. Just give me a little bit of time. So we got f of x. Now, we don't really have a property for a cube root. But if I raise it to the 1/3 power, we're good to go. And you got that plus that. So we're in good shape at that point. So take your roots, always put them into a rational power. So now I will just do the derivative of this is going to be 1/3 times the stuff, which is a highly technical calculus term. What's 1/3 minus 1? Negative 2/3. Now, is the stuff x? No. So I have to differentiate the stuff. Times negative 8x cubed. All right. So now, this you should simplify because we don't like negative exponents. So I guess the rules of simplification will evolve as we get through these problems. We don't like negative exponents, so we want to put it into a decent way of doing this. I'm going to get 8x, that's up top, right? 8x cubed is up top, 3 is on the bottom, and then you could just do this. Good catch. Good catch. You can leave it as a rational power because those are easier to write and those are easier to deal with than writing a cube root of that squared. So just keep it as a 2/3 power because it's, like I said, it's easier now this is the rate of change of the original function at any point of x. It's easier to type it into a calculator in this form than it is if it was a cube root of something squared.
I have a question. Okay, what if you incorrectly put -8 x3 over 3 and then put the line under that? Because I always forget to move the 3 with the bottom.
Technically, no. But that's a complex fraction, so it could be simplified even more. Just think.
I always forget to move it with
When you're going through these, just think about what's going to go on the top and what's going to go on the bottom. And when you get a negative exponent, all that stuff goes in the bottom. Well, you already got something in the bottom. You look at each thing and say, does this go in the numerator? I shouldn't say top and bottom. I should use math words. Numerator, denominator. What goes in the numerator? What goes in the denominator? So just try to think of it like that. And if you go 8 over 3 and then over something else, that 3 is going to go down into the numerator or denominator anyway. 10. Ooh, they gave you a lot of space for that one. That must mean it take a lot of room. All right. I'm going to do the u and the v for this. The u is the top, which is x cubed plus 4 to the 5th power. What's u prime?
5 times x cubed plus 4 times...
What's the power? Now, do I have to do a chain rule?
Yes.
All right, so it's going to be times.
3x squared.
All right, and I'll simplify that down to 15x squared times x cubed plus 4 to the 4th power. Yes, sir. Yeah, if it's raised to the 4th power, you can't get inside of it. You have to pay that cost of getting in by raising that to the 4th power to get inside. So, yeah, because it has to be a 4th power. So the only way that this could go inside there is if this was to the 4th power as well. Only the same powers can be merged together like that. All right, so v is the denominator, which is just 3x to the 4th minus 2, which thankfully is not that big a deal. 12x cubed is xx? Yeah. Do I need a chain rule? No. Is the chain rule there in the background? It is, but we don't care. All right, so now y is going to be, let's move over here, zoom it out so we can actually see everything on the video. Y is going to be a monster quotient. It's going to be that 3x to the 4th minus 2 quantity squared. I need the derivative of the top, which is 15x squared x cubed plus 4 to the 4th times the denominator, which is 3x to the 4th minus 2. Oy vey. Minus the derivative of the bottom, which is 12x cubed, times the top, which is x to the 3rd plus 4 to the 5th. Now, like if I'm giving you a quiz, I'm going to be really focused on this part, and the majority of your points, like if I said, all right, I'm going to give you 10 points for this, I would say 8 out of 10 would be, can you get from here to here? Everything else would be algebra. The only way that I could think that you could simplify this is to start factoring out common factors. And so I'll just do that just for fun. 15 and 12, what's the common factor? 3. X squared and x cubed, what's x squared? I have x cubed plus 4 to the 4th, and I have x cubed plus 4 to the 5th. Alright, and the stuff that's left over here is going to be, well, I got rid of the x squared. 5 times 3x to the 4th minus 2 minus 4x times x to the 3rd plus 4 all over 3x to the 4 minus 2 squared. And then, well, no. You could, but there's actually, you can make it look a little bit nicer. What? Common factor of the 15, the 12, and the x squared, and the x cubed. Now, if we multiply this, that's 15x to the 4th minus 10 minus 4x to the 4th minus 16. So, oh yeah. Yep. Alright, so y prime, 3x squared times x cubed plus 4 to the 4th times 15x to the 4th minus that's 11 x to the 4th minus 16x minus 10 all over 3x to the 4th minus 2 squared. And that's as far as you could simplify it. On this, I probably would just say get to here. But you need to be prepared to get to here. And it just ends up being an algebraic exercise at that point. Alright, and last but certainly not least, number 11. I'm looking at this guy. Don't ask me to do this one. I might do that one later and make a video of it and put it online for you. Because it's nasty. Well, it's not nasty. It's just nasty. All right. Number 11. All right. This is just a power rule to start with. If you covered up everything here, it's just. Well, here's where I would actually use a u. I would say u is equal to x plus 5 to the 5th minus 1. Because that's all the stuff that's the inside, because then y would be equal to u to the 4th, and y prime would be equal to 4u cubed times u prime. Does that, well, first off, does that make sense and how to apply the chain rule that way? Doing a u substitution and doing that. Now, the reason why I do that is because if the stuff gets complicated, sometimes it's a lot harder to do it in your head. And you start making little mistakes by missing a sign here or missing a power here. You've seen me do it a little bit here and there. I'm trying to make sure that like 4,000 things are going right at the same time up here. U prime, power rule here, 5 times x plus 5 to the 4th times, well, what's the derivative of the inside? Just 1, which is nice. If it's just x plus something on the inside, it's almost like it's an x, but it isn't really. What's the derivative of negative 1? 0. So it's like plus 0. So it's really just 5 times x plus 5 to the 4th. So now what I'm going to get here is y prime is equal to 4 times u, which is x plus 5 to the 5th minus 1 to the 3rd times 5 times x plus 5 to the 4th. And the only thing that I would do to simplify this guy is my math OCD pops in and says, all right, I got coefficients, that's 20. I have something to the 4th power, so I'll put that out front because it's been beaten into my skull for 35 years that when I have something to a power, the highest power goes first, the lowest power goes second. Yes. Here? I applied, since this wasn't directly an x right here, I applied the chain rule. So I took the derivative of the inside. So the derivative of x is 1. So that's where that 1 came from. And it'd be plus the derivative of 5, which is 0, so it's just 1. Yeah, you could end up skipping that step. But just make sure that you do still have the chain rule. The Charlie Romeo chain rule. And so at that point, this would be my answer. And I just prettied it up a little bit. Made sure that the power went in decreasing order because of my math OCD and the actual rules that say you should probably put stuff in decreasing order because you're going to get professors that have even more math OCD than I do. That might tell you you're wrong for having it the other way, even though you're right. And you can argue with them, but I don't know how far that'll get you. Now, really quick, give a function that requires 3 different applications of the chain rule. I showed you one that had like 7 different applications of the chain rule. So, anybody come up with something fun? Yep.
Parentheses, 5x minus 3, parentheses, to the 5th power, times the cube root of negative 3 to the 4th power, minus 2, whole thing in parentheses. Oh, you're writing it down. I'll say it. Negative 3x to the 4th power, minus 2. And then everything in parentheses.
Yeah, that would do it. That's pretty ugly. That's a good one.
Yeah, I just looked at number 12 and I just changed it.
No. Hey, well,
And then I added another thing.
I would have went like sine, cosine, something like that. All right, let me attempt number 12.
You don't have to do it now. It's okay. It's okay.
All right, I'll do it later. I'll do that one, throw it up online. Keyword throw up.